So, hi, I'm David. I really like cold water immersion. It's a practice that I do every day. And periodically, I like to review the evidence base, just check my practice, how it relates to what the scientific and medical communities are finding as they explore and look into cold water. So, this is part four of a series where I'm looking at a paper called Health Effects of Voluntary Exposure to Cold Water, a continuing subjective debate. And in this part, we're going to look in detail at the physiological responses to cold. And the last time we looked at some of the high level summary, now we're going to get a bit more in depth with it. We're starting with thermoregulation and skin blood perfusion. What the hell does that mean? So perfusion is in part the flow of blood through our circulatory system. So that's what perfusion means. It's just the flow of blood. Thermoregulation is our ability to control our temperature. And so we're looking at how the skin can control our temperature. And there's two ways that this occurs, and it comes in two phases. The first stage is when we go into cold water, we get a constriction, a vasoconstriction. This is the blood vessels that are transporting the blood through our skin. They get really small and stop the flow of blood through the skin. And that's to protect it. There's a couple of things going on there. One is it stops the blood from being exposed to the cold environment, which means that it's not going to be cooled so quickly. And also the change in blood pressure forces the blood to protect our core organs and most importantly our brains. And that's quite a deep, rapid change in our bodies when we go into cold water normally. I mean, there are always exceptions. And yeah, so this is a detailed description of what I just said. So I'm not going to go line by line. I don't feel that it's necessary. Some of the interesting stuff is around what controls the body, what makes the body decide that it needs to act in this way. And just picking up here on things like there's a connection to the sympathetic nervous system. So when we're immersed in cold water and our core temperature drops to about 37.1 degrees, that's when we start to see the constriction of the peripheral blood vessels. So this effect isn't so pronounced at what are considered to be thermoneutral, so neutral temperatures, which is in the range roughly of about 20 to 30 degrees. It notes that there's only so much that the skin can do to control our temperature, and if our core temperature keeps falling, then eventually we switch into other ways of controlling our temperature, such as shivering. Shivering is a good example. Quite a dramatic drop in the core temperature for that to happen. So looking around 36.2 degrees is mentioned there. The really interesting part around the ability of the skin to react and control our temperature is that there is a large variation in this response when we're immersing in cold water. So they did a study where they used infrared technology to look at the ability of healthy people to deal with the cold using Norwegian army conscripts. Yeah, there was variability, and in 10% of people, so 1 in 10 people, had a much slower rewarming of their hands after the test. It's really important to remember that there's such a dramatic difference between us all that we need to consider that when we're looking at taking on a cold water practice and working out where do we sit within our ability to the ability to control our temperature, and we need to respect that. And we need to practice in a way that works with our experience of the cold, not to get too carried away with trying to keep up with what anybody else is doing. So it's really important to remember it's a very individual experience, and that we need to take care of ourselves and learn how to take care of ourselves in cold water.